This is chapter 8, side problem, page 138. Try this problem. So this question is providing information AD perpendicular to BD, AD and BD. That's why we need to be careful about this what lengths are perpendicular to each other, not AC and AB, not whole things, just a partial, this part, right? These two perpendicular, AB perpendicular to AC. And then given that DC is 1, AD is 6, and trying to find the shaded part of this shape. We should always start from isosceles triangle and making a perpendicular foot. That is must do steps first, and I'm going to make create that line, perpendicular line, perpendicular foot, line segment and foot. So what happens when this perpendicular foot makes into two equal side, but we don't know this BC, but why don't we just start with saying A, and this becomes A plus 1. Okay, great. Now I would like to remind a couple theorem about right triangle and similarity connection. Those two, or maybe I would provide 3 A, B, C, say K, L, M, N, and H. Because of the similarity, there is a nice connection. K square equals to M times whole base, as well as L square equal to N times from other side whole base. We are going to use this one definitely. Then we might use another famous one, H square equal to M times N. That's another useful one. Let's see. How am I going to use this one into this problem? It's got to be 90 degree, right? That's why I'm going to focus on a triangle, this triangle ABD. So if I focus this triangle ABD, then I am going to write K square or L square equal to this part and whole part. So I'm going to write here 6 square is equal to A times A plus 1. 6 square becomes A times 2A plus 1. Yeah, I should say this is 36. Then you could do solving quadratic equation, but I can see that the value of A appears as 4. 4 times 9, 36. Then the second step would be, so I'm going to replace A. So here is better for us to get another nice figure here to show you the last step. What we got here, that's very nice, 4 and 5. So now we need, in order for you to figure out this shaded parts area, you have to have height, altitude of this this triangle, then I'm going to use this formula. H squared equal to 5 times 4, and h equal to root 4 times 5, then h equal to root 5. Then area of these shapes become 1 times 2 root 5 divided by 2. Then that is going to be my result as, I'm going to say root 5 would be the area of this shaded triangle. So do you see that there's a multi-step problem? We use a couple previous right triangle similarity connection. Those are very useful, definitely. Now, chapter 8, page 139, try this problem. It's about combination of Pythagorean triangle, Pythagorean formula, and a couple other algebraic manipulation. Of course, what do we know about this triangle? Let's say, why don't we just write, first of all, a squared plus b squared, of course. That's my favorite one. Then a c squared. So then we are going to definitely use that one. Then what else? So and then the other formula is very interesting to use. A plus b squared is equal to, so a squared plus b squared plus 2ab. So we are going to definitely use this one. So these are the two main formula we are going to use during these solution steps. Okay, let's start. I think you might think that putting a square, replacing a square plus b square into c square would be a good idea, very intuitive idea for all of us, finding the value of c square, even the finding value of c, 12. That's okay, but we don't need the length of the hypotenuse. We need really what? Area of this triangle. Let's identify what we need. Area of this triangle means we need the AB over 2. So we need A times B, the product of these two legs, divided by 2. Let's see, we have not used the first equation yet. A plus B plus 12 is 28, then A plus B becomes 16. Okay, very good. So we need a b over 2. Then what do we know? So we know a plus b is 16. So what do we know? We know also a squared plus b squared is 144, which is 12 squared. I can write this way, 12 squared is better. So now this two piece of information possibly give product of A and B. Let's see what formula, what algebraic manipulation I am going to use. This guy. So what I am going to do, I am going to replace A plus B is, again, I'm going to write this one more time. A plus B squared is equal to Oh, I can do this way. A square minus b square is equal to 2ab. Oh, even I can divide it by 2. That's fine. I can do the next step. So why don't I go just replace a 16 square and a square plus b square is 12 square 2ab. Even I want to avoid hard work, be smart, using difference of 2 square. Another nice application of algebraic structure. Now 16 minus 12 times a minus b and a plus b, 2ab, then 4 times 28 is equal to 2ab, and final step will be just dividing by 2 to each side. AB equals 20. AB becomes what? Becomes is just 2. Then AB is going to be 56. Wow, hooray, hooray. We got it. Oh, yeah, AB is 56, but the answer becomes, the area becomes 28. Why? Becomes area is AB over 2. 28 would be my answer. Oh, what a coincidence. It becomes a plus b plus c, also 28. Okay, we got this one. We use a bunch of algebraic manipulations and effectively use of the given information. That's end of the page 139 side problem. Okay, now we are in page 141, chapter 8, side problem. When we look at this problem, given information 2 equal line segments and 3 giving 6, 14, 14 areas. So let's see. First of all, area and base connection. So we know that area and base connection. That means if, so I would like to just make this one. If this is 6x or 6 to the 14, which is going to be 3k and 7k connection. If this side is 3k, this side has to be 7k. The reason is because it shares the same height, and the area ratio becomes the just related base ratios, which is 6 over 14, 3 over, which is 3 over 7, 3k and 7k. We got it. So then I really need to know what would be this 2 ratio be? 1 question mark over 2 question mark be. So to understand that one, we can use different techniques, but I would prefer to go into the parallel line connection. That's my favorite one. If you go to that parallel, you can use also mass point or Menelaus, whatever we call those things. So if you go from here, the first thing you can notice that this is these 2, since this is this equal 1 to 2 ratio, this is going to be 6k. Because the reason is 6k, because these 2 triangles, you see that same length, these are also same. This is 1 to 2 ratio, which is going to be 6k. Okay, then I am going to focus on another blue. So now this triangle, small and big triangle. So that is going to be, the ratio is going to be, here I would like to explain here, AE over AC becomes 6k over 3k plus 7k, which is 6k over 10k, which is 3 over 5. So now AE, the value of AE is 3k, then the value of AC becomes 5k, then this becomes 2k. So that's very nice. So where are we now? I would like to just draw that situation. Now we have, I would like to just draw B and E, because I got the 3k and 2k. I got here 28 area. Whole area is 28. So 2k gets 28. What about, I don't really need that 6 part. I need just whole area, because these guys share the same height. Just I need to look at the, if the 2k gets 28, what about 3k gets? How do I know that? And then I can see that 1k gets 14 and 3k gets is 42. That's going to be 42. So if this is 42, and this part is, I can say that this part is 6, then the quadrilateral part becomes 42 minus 6, then it's going to be 36 would be my answer. So again, this part, the quadrilateral area becomes, again, 36 unit square. So that is the end of the page 141 solution. So this one, page 142, chapter 8, side problem that relates to the area. This figure, maybe it's not clear, but this figure should represent the trapezoid. Just kind of you will see that the here trapezoid fixed version. So if it is trapezoid, and how do we do that? One way to approach the trapezoid problem, making a what? Making parallelogram inside the trapezoid. Then once you make this parallelogram, you can see that this is going to be 5, this is going to be 5, this is going to be 3. And do you notice that 3, 4, 5 triangle creates a right angle? Then you know that the value of this part in terms of the area becomes 6, right? 3 times 4 divided by 2 and 6. Now, how do I know that this is 5? This is 5, and then I can make these another pieces, and then this area, these all equal 6, 6, 6, 6 plus 6 plus 6 plus, that's going to be 18. The whole area becomes 18. Yeah, we can have a couple different solutions. So I would like to also erase this one to show that solution. One solution would be, again, once you create this parallelogram, 3, 5, and 5, and you can see that this is 90 degree and this is also height. Then from the triangle, you can say 3 times 4 is equal to 5 times h, and then h becomes 12 over 5. then you can use the area of the trapezoid, which is, so area of trapezoid becomes the sum of two bases over 2 times height, which is 12 over 5. When you do calculation, you will also get 18 unit square from this one. Finding height, and once you find height, you know the area of this trapezoid becomes sum of two bases, average of sum of two bases times height. That is end of the page 142 side problem. Okay, let's take a look at page 143, chapter 8, side problem. When you have trapezoid or two parallel sides and angle bisector, you have to look for a special case, which is called isosceles triangle. That's the aha moment of this question. If this is alpha, this becomes also alpha. Then we notice these two sides, which is DC and EC, actually they are equal. So keep in mind, two parallel sides and angle bisector always create an isosceles triangle, as we see here, and we found isosceles triangle. That's very nice. So far, I would like to move this shape here bigger and create. And what was the other things we have to keep in our mind? Always making a height. So now I'm going to make a height of these attitudes to perpendicular foot. Let's see. Then I can transfer this 8 to the here, 8. And if I focus on this triangle, blue triangle, then, so what do we see that? We see that there is a special triangle, or it's not special triangle, well-known triple, that is going to be 6, right? Then what do we see? That if this whole thing is 10, then this part becomes 4. So EH becomes 4. Because 10 minus 6, 4. Then the value of BE becomes, and you all observe and see that 2, because 6 minus 4. Then we can use either two triangles concept. So you can use even this rectangle and another triangle, or area of this trapezoid. So area of this trapezoid becomes 2 plus 6 divided by 2 times height. 8 divided by 2 times height, that is going to be 32, becomes our area. So finding height and finding those two missing pieces. Technically, from the beginning, you are thinking that, yes, you need to find BE in order to find the area of the shaded part, area of this trapezoid. So all things related to finding length, and then it's easy for you to find the area after. That is, so that was end of the page 143, chapter 8, side problem. Chapter 8, side problem, page 144. Let's see. We only know that, okay, we have a couple of information. One is, this is midpoint. M is the midpoint, which is 7 and 7. I don't know the value of this guy, which is we are looking for an x. Good. But what information do we also know? Okay, shade area. So we know that the whole area of this square Q, is 14 times 14, is equal to 7 times P. That's why this information, when you divide it by 7 each side, then it's going to be 228. You obtain the area of the shaded part, which is we call the P. Then after that will be a nice and easy step for us. The expression area in terms of two legs, 7 times x divided by 2 will help us to figure the area. So then that is going to be 56, 7 times x, and divided by 7 each side, then 58, the value of x, which is an, will be the unknown part of that shaded square. So that is end of the chapter 8.